This is a circle. This is having a diameter. So secant, this point is P, this point is Q, this having center O. So this is having a tangent that is called as xy, and this is having another tangent that is called as x dash y dash. For these 2 points we are getting one more tangent that is called as point B. Point of contact is C. Here you are getting A. So this one is x and y tangent. Now see, from here, so we have to find out angle A, O and B. This one we have to show that it is equals to 90 degrees. For this purpose what I am doing is, I am dividing this one. We are drawing a line from the center to the point of contact at point C. Point of contact at point C. So is that clear? Now see, I will show the question once again. See, this is the figure. Xy and x dash y dash are the two parallel tangents of a circle with center O and another tangent AB with point of contact C, intersecting xy at A and x dash y dash at B. We have to prove that angle AOB equals to 90 degrees. So this is the same figure which I am drawing right over here. See carefully. Now for this one I am going to explain the steps which I already written back side of the page. Now see the problem clear. Now see these are the steps given. Xy and x dash y dash are the two tangents touching the circle at the point P and Q, and AB is another tangent with a point of contact C, touches the one tangent xy and another tangent x dash y dash at point P. Now we are joining OC, and if you join OC, OC will be perpendicular to OB. As I said that in this figure, see, we are drawing a radius from the point O to the point C. Here we are getting the tangent. We are getting two right angle triangles. One is AOP, another AOC. Here, in triangle AOP and AOC, if you take common, AP is equals to AC. Why? Because tangent from the point of contact. OA is equal to OA, which is a common side, and OP is equal to OC. OP is equal to OC, which are the radii. So by side congruence, angle AOP is congruent to AOC. Angle 1 is equal to angle 2. In triangle BOQ and BOC also here getting the same thing. BQ is equal to BQ. Why? Because tangents from point B. Tangents from point B. Here what is the common thing? OB is equals to OB, which is the common side. OB is equal to OB, which is a common side. And one more is OC is equals to OQ. OC is equals to OQ is nothing but radii of same circle. Radii of same circle. Now see, by here also side congruence. By side congruence, what will write? Triangle BOQ is congruent to triangle BOC. Here we took angle 1 and 2. Here we are taking angle 3 and angle 4. So angle 3 is equals to angle 4. Angle 3 is equals to angle 4. So if you add all these 4, what you are getting? Yes. By these you are getting by corresponding parts of congruent triangles. By corresponding parts of congruent triangles. So if you do angle 1 plus 2 plus 3 plus 4, see how we are getting. See, angle 1, angle 2, angle 3, angle 4. These are the 4 angles which are on the diameter. Diameter which is a straight line. Straight line means how many degrees? 190 degrees. See, angle 1 plus angle 2 plus angle 3 plus angle 4 is equals to 180. In place of angle 1 we can write angle 2. Angle 2 plus angle 2. In place of angle 4 we can write angle 3. Angle 3 plus angle 3 is equals to 180 degrees. So 2 angle 2 plus 2 angle 3 is equals to 180 degrees. Why you are taking especially angle 2 and angle 3 means here you are asking angle AOB value. So that's one. If you are taking 2 common, angle 2 plus angle 3 is equals to 180 degrees. So 2 ones are 290. Angle 2 plus angle 3 becomes angle AOB equals to 90 degrees. That's it. So this is hence proved. That's it. So if you want this angle 1, angle 2, I will draw in this figure. Carefully see. This becomes the angle 1, this becomes the angle 2, this is angle 3 and angle 4. See, we have to find angle A, O and B. So for that one we are getting angle 2 and angle 3 only. That's why we are writing here angle 2 and angle 3. Now those who are writing, please see the video clearly. Yes, so this is about the complete problem of question number 9. Now see question number 10. Yes, question number 10. Yes, this is the 9th one figure. Now we are going for the 10th one proof we have to show. Now see what is the 10th question. So what is question number 10? Prove that the angle between the two tangents drawn from an external point of a circle is supplementary. The angle between the two tangents drawn from an external point. From the external points we are drawing the two tangents. The external point which is touching the circle, that we have to prove that it is equals to 180 degrees. The angle subtended by the line segment joining the points contact at the center of the circle. So which is nothing but very easy. Yes, now very simple. This is a circle and this one is one tangent and this is the one tangent drawn from external point. So here we are getting the circle, center of the circle. Generally I am taking this as center of the circle. Here we are getting the two perpendicular lines. Oh, this one is the point of contact from the external point. Here I am taking the point of A and B. That's it. Like this you have to. So we have to find out this angle. This angle. That means angle. We have to find out the entire of this one. So this one. Generally I drawn this line. This line is not important. For showing purpose I have drawn this one. And generally you have to draw the figure like this. Circle and two tangents and this one center of the circle and this one is a two perpendicular lines. We are getting A, B, this is at A. So this one and this one I am taking angle X and angle Y. Generally if you draw with the lines, so this angle we have to show which is a supplementary. That means X plus Y we have to show that 180 degrees. That's it. Now see how we are going to write that. Given PA and PB are the two tangents of a circle with center O. Now see, OA is perpendicular to PA. Why? Because radii is perpendicular to tangent. Radius only. Radius is perpendicular. If you are getting one radius, that if you are getting from the center of the circle to a point on a circle, one line, that is called as radius. If you are getting more than one, it is called as radii. So radii perpendicular tangent means angle PAO is becomes 90 degrees. One more, OB is perpendicular to PB. Here also same. Radii is perpendicular to tangent. For this angle PBO, which is equals to 90 degrees. This is also 90 degrees, that is also 90. For this one 90 degrees we are taking as angle A, this one 90 degrees we are taking as angle B. Now see, in the if you see the quadrilateral angle in a quadrilateral, what is a quadrilateral? PAOB. In a quadrilateral, sum of all interior angles of a quadrilateral is 360 degrees. So what you write? Angle P plus angle A plus angle O plus angle B is equals to 360 degrees. So angle P is nothing but y plus angle A means 90 degrees, angle O means x plus 90 degrees is equal to 360 degrees. So if you write in the order, x plus y plus 180 degrees is equals to 360 degrees, bring it to right hand side. X plus y value becomes 360 degrees minus 180 degrees. So x plus y we are getting 180 degrees. So we proved that the angle between the tangents, the angle between the tangents is supplementary. So like this you have to prove this theorem. Yes, please write it down. Both are same figures, you can draw anyone, either use this one you just close it, you can write this one theorem. That's about the 10th one. Now we go for the 11th one. What is the 11th one, which is very very important and very very easy also. Now I'll write the theorem number 11, that is very important. Prove that the parallelogram circumscribing a circle is a rhombus. We have to prove that. What you have to prove? A parallelogram circumscribing a circle is a rhombus. We have to prove that. Prove that the parallelogram circumscribing a circle is a rhombus. For example, this is the parallelogram. So if you take a circle inside this parallelogram, general, so this we are not getting properly. So let me draw the parallelogram first. Yes, this is a parallelogram. So here we are able to get the touching the point. So don't think I'm not getting the circle properly, you can draw the circle properly. So this we are taking the sides A, B, C and D. We are taking 4 points P, Q, R and S. So this is center point O. Just if you are joining the center point to the tangent point of contact as one radius and one tangent AD, we are getting the yes. So from the center of the circle we are drawing a radius at the point which is touching the tangent of the circle as P, and one more tangent AD which is touching the circle at the point S. From the center we are drawing the point, one more point is called as Y. Now said we have to write the proof. What is the proof? Given that ABCD is a parallelogram, and in a parallelogram opposite sides are equal. In the parallelogram opposite sides are equal. Which are sides are equal? AB is equals to CD, and AD is equal to BC. So in a parallelogram opposite sides are equal. In a parallelogram opposite sides are opposite sides are equal. Now see, now from center join OS and OP. After that what you are getting? OP is perpendicular to AB. Now you can see, if you join OP perpendicular to AB, and OS is perpendicular to AD. Now if you see this one, if I draw a line like this, here you are getting the two tangents. The length of the tangent drawn from an external points are equal. That theorem we are going to use here also, compulsory. By that one, what we have did, we did this problem in the 8th one, the same we are going to use here also. What is that? AP is equals to AS, BP is equals to BQ, CQ is equals to CR, DR is equal to DS, with the tangents from a point A. Now see, tangents from the point A, tangent from the point B, tangent from the point C. Yes. Now see, tangents from the point D. So this is equation 1, equation 2, equation 3 and equation 4. Now adding equation 1, 2, 3 and 4. If you add these 4, what you are getting? AP plus BP plus CQ plus DR is equal to AS plus BQ plus CR plus DS. AP plus BP will become AB, CR plus DR becomes CD, AS plus DS will become AD and BQ plus CR will become BC. So this is become, yes. So we already know that, see, in the parallelogram opposite sides are equal. We already know that in the parallelogram, in a parallelogram opposite side, in place of AB we can write CD, in place of AD we can write BC. See, AB plus AB is equals to AD plus AD. We wrote this one from the opposite sides are equal. In place of CD we are writing AB, in place of BC we are writing AD. AB plus AB become 2AB, AD plus AD become 2AD. So 2 will be get cancelled. AB is equals to AD. So AB is equals to AD. AB plus we can write AD. See, if AB is equal to AD, if AB is equals to AD, then AB is equal to CD, CD which is equals to AD, AD which equals to, we can write AB, AB you can write as BC. So you can write all AB is equals to BC is equals to CD equals to AD. If you write in proper, AB is equal to BC is equal to CD is equal to AD. So in a rhombus, all the four sides are equal. In a rhombus, this is the rhombus, we know rhombus, all the four sides are equal. Yes. Now see, AB which is equal to BC which is equals to CD and AD. So if you draw like this, A, B, C, D, AB, BC, CD and D, all the four sides are equal, which becomes a rhombus. So therefore what we will write? Parallelogram circumscribing a circle is a rhombus. So this is a very important problem. You can keep star mark also. you may get for 3 marks or 5 marks. Compulsory you are going to get the problem, this one. So 2 more problems are left, 12th one and 13th one, that I will explain in the next session. And along with these problems, some example problems and some other problems also I am going to explain. 12th one and 13th one, 2 problems left. According to these 2 problems, I am explaining remaining example problems, and which are the previous year question papers also repeated, that I will explain in the next after 9 p.m. I am going to come to the live session. At that time I am going to explain that one.